Okay, right. The next thing to do is to share the slide. Share screen. Share the screen. Okay, I hope my voice is loud and clear, and I'm currently going to share with you something which is chapter 5. Chapter 5, we start with two sample hypothesis tests. So hopefully this is being displayed. The slide is displayed on your screen, right? So, okay, so previously we have went through the one sample test for proportion, or we could say one sample test hypothesis lah, and we also learn about p-value, the level of significance, and also the confidence level, the rejection region, okay, whether it's a two-tail or one-tail. For example, do you have a graph, normal distribution here? If you look at this one, so normal distribution, normally you have the peak at the middle, so it will show a bell curve. Okay, it looks like a U. So the rejection region is at the tip of each of that line. So the rejection region, if once you calculated, right? For example, you use the formula, then you calculate that the answer is within the rejection region, then you reject the null hypothesis. If it is not in the rejection region, for example, you look at this example here, when they calculate the T, the formula T-test, see, we have type of test. So this is the T-test for unknown. So if you calculated and then you get negative 1.05, yes, it is a negative. Why? How do you know when you want to draw this graph? Okay, you want to immediately shade the region, whether you want to shade it on the left hand side or you want to shade it on the right hand side, okay, the shaded region. So you look at this when you look at the question, right? So after you read the question, where's the question? The question is very far up here. Okay, so never mind. When you read the question and then you draft the hypothesis testing, so the red part here is the hypothesis statement, right? So we have a null and an alternative hypothesis. So the null hypothesis is the one that is the existing theory or what has been normally discussed or been agreed upon previously. So the mean response time is more or less than 25. So once you know there is more or less, you immediately automatically put the alternative as more or equal to. Once it is more, it has to be an inverse suggestion. Inverse is berlawan. So once you put your null hypothesis as more or less 25, then it should be less. Okay, so when it is less, then it is on the negative hand side of this normal distribution curve. Okay, so you shade this left hand side, the left tail. Okay, if your null hypothesis, of course you read the question and then okay, maybe it is for example less than or equal to 25, then it has to be inversely stated more than 25. Okay, so dia kena berlawan. Alright, so that is regarding how do you shade the region. So if it is more than 25, then you shade it on the right hand side of the curve. Okay, so and then when you do the calculation, of course all of this information are given. For example, the number is 44. Okay, and then you have the formula whereby n minus 1 is 43. y minus 1, that is the formula. Okay, so in order for you to find the critical value, because you want to know whether you want to reject or accept. So how do you know it is 1.68? Okay, because we are using the level of confidence. So within this unshaded region, right, is 0.95. Okay, 0.95. 0.95 is the level of confidence that you are confident that it is the alternative hypothesis. Okay, 95% is within this region, this unshaded region. That means if when you do calculation, when you got the answer, and then it falls within this region, this unshaded region, that means you fail to reject the HO. Okay, you fail to reject the HO. Okay, it does not fall in the rejection region. Okay, because if you do the calculation and then it is inside here or more than this 1.68, for example lah, it can be 2, it can be 3, it can be 4, negative lah. Okay, this side, that means you can actually mention that you can reject the null hypothesis. What does it mean? You reject this statement, you reject that means you can cancel it. You say that, okay, I'm correct. This statement, alternative hypothesis, is your test, is your statement. So you can say that I'm rejecting this and my test suggests that, yes, it is true. My test, it is less than 25. Okay, so same goes to this one. Since that, when you do the calculation, negative 1.05 is not within the rejection region, then you fail to reject. That means the existing theory, the existing statement that mentioned that the mean response time is more or equal to 25 is true. Okay, so that is what it means. All right, and then of course you have this kind of rejection region. So when you have a two-tailed test, this now was one-tailed test. So when you look at the vacation survey, this is one of the data set lah. And then they want to test whether the average age respondent is equal to 35. So normally when you look at this statement, when they immediately say equal, then one should be like this, and then another one should be not equal. So remember, when we go back to the statements of when you want to do statement of hypothesis, this is the rule, the rule of thumb. Okay, in order for you to construct how to construct the perimeter and the constant. So number 1 and number 2 is always inversely from inverse statements from each other. One should be more or less, one is more and one is less or equal to, and then one is more or equal to and one is less. Meanwhile, for this one, so number 1 and number 2 will immediately, when you want to do a graph, you will do for this one, if it's like this, okay, remember if like this, what type of graph? Is it mana graph tadi? Okay, this one better lah. I show you this one. Alright. So when you do this one perimeter, so the rejection region is this side. Okay, you just, if you kind of very hard for you to understand how to draw it, then you look at your alternative hypothesis. So when you look at the alternative hypothesis, you look at the symbol. You look at the symbol and then you see that this is pointing towards the left hand side, which is less than. So when it's less than, then you draw the graph like this. Okay, so this, then you shade the left hand side of the graph of this normal distribution graph. So it's lower one-tailed test on the negative side. And then if you look at the alternative hypothesis and then you look at the null, the alternative hypothesis, you look at this arrow, pointing towards the right hand side, then you also draw it and then shade it on the right hand side. Meanwhile, for constant, for two-tailed test hypothesis, you shade both. Okay, so both of these. Okay, we have, for example, if we use a 0.95 level of confidence, okay, level of confidence meaning that if it's fall inside this thing here, then you fail to reject. That means the level you confident that about 95% the null hypothesis will be correct lah, because you fail to reject. Okay, because this one is in rejection area, rejection indicator. So when you do the t-test, but for this one, for two-tailed test, it's no longer a t-test, it will be a z-test. Okay, different. This one using t-test. T-test, test statistic. Let me see. Oh, there's a known and unknown lah. Okay, known and unknown. Okay, so hopefully you understand regarding what it is for two sample hypothesis tests, when to use the one tail test and two tail tests. Okay, so this one, we back to this lower sample hypothesis test, right? So we have a lower tail test. Okay, so minum dulu. Okay, so null hypothesis, for this example, the population parameter, and then the population parameter 2. Okay, we have two types of variables, and then alternative hypothesis also have two types of variable. Okay, so this test seeks evidence that the difference between population parameter 1 and population parameter 2 is less than some value. Okay, then the value should be around this one. And when this value is equals to 0, the test simply seeks to conclude whether population parameter is smaller than population parameter 2. Okay, so upper tail test, which is lower tail test. So you can see a lower tail test, remember, you look at this alternative hypothesis arrow. So when you draw a graph, remember, when you draw a graph, then you shade it on the left hand side. So that is what we call as lower tail test. Lower tail test, when you do the shaded region, is always on the left hand side of the end of the tail. Okay, so the tip of the graph, the normal distribution, normally we say it as the tail, called here. Okay, this one is upper tail test. So this test seek evidence that the difference between the population parameter 1 and 2 is greater than some value. Okay, it's vice versa, inversely stated. And then of course we have the two-tailed test. Okay, two-tailed test is equal sign or not equal lah. So the test seeks evidence that the difference between the population parameter is equal to the value. Okay. Okay. There is a tool pack in your Excel that you can enable in order for you to do this type of test. Okay. I'm not sure if you have in your Excel. Let me see. Analysis tool pack. Not this. It's not this one. Where are you? Okay, right. See this one? Yeah, this one. Analysis 2 pack. Oh, okay, this one lah. You can do the Z test, T test, T test. Okay, sometimes your computer or your laptop do not have this section. So for Mac lah, because I'm using Mac, you can go to Home or File. This one kah? I think yours should be a Windows or what? The very end here. If you go to the top right hand side, for you to enable it, system setting. No, not this one. File, properties kah? No, I forget already how did I enable it. But for Windows, there is, I forgot how it looked like. There's a section here lah, somewhere there, for you to actually enable that analysis toolpack. So so that you can use this thing. Where the one? Like this. We have a t-test. So it automatically, for example, if you select a data set, okay, let me, is there an example or not? Will they show you example how to do? Okay, there is. Using purchase order database. Okay, so go here. For purchase orders. Okay, this one. Right. So previously, all of this thing has been done already. They show you the T statistic answer, hypothesis mean, degree of freedom, observation, the variance, the mean. Mean is the average of all of this in K, lead time. Okay, so this is a t-test 2 sample, assuming unequal variance. 2 sample, where's the sample? There's only one here. Okay, so from this H, so this parameter 1, parameter 2. So one is minus, it should be less than or more or less 0. And then your alternative hypothesis, you yourself trying to state that when you minus these two, it should be more than 0. Okay, so this is, they want to test the mean lah, because this one is mean, right? This you look like you lah. Not you, but you, this one. Okay, so when you minus the mean, the existing statement or theory suggests that it should be less than or equal to 0. But your statement is when you want to test that, when you minus the parameters, the two of the parameters, it should be more than 0. Okay, so your hypothesis should be look like this. Remember, this arrow already suggests that you should shade this region. Okay, And then this will be called an upper one-tailed test, rejection region. Okay, so based on the t-test, t-statistic, and the t-test there. Okay, so 7 minus 4.9 is around 3.1 kah? 3.1 betul kah? So the answer here is the answer was reject the null hypothesis. So why do we reject the null hypothesis? Because if we were to reject the null hypothesis, then the answer should be within the rejection area. So where is the answer here? And then what kind of level of confidence did they use? Okay, not mentioned, level of confidence. Okay, so these are types of, what do you call this? Example, but never mind, we go one by one for the slide first. At least we know where to refer later on once we look at the slide one by one. Okay, here. Okay. So when we want to refer to the Excel sheet just now, we already know that we need to enable the analysis toolpack in order for us to easily do the analysis later on. So these are the types of tests, and when you enable the Excel, which one for you to use? For example, okay, here. Let me close this. Okay, try. This is a bit small. Okay lah, right. Hope you can see this. Okay. Now, the first one, two sample tests for mean. Two sample tests for mean, which is known. So you use the Excel z-test to sample for mean. Okay, so where do we find it? Let's say we have this data set, right? So we go to the place where there is the analysis tool just now. Oh, tak nampak. Okay, where's the analysis tool? Here, right? Data analysis. So two sample tests for means. So the mean is known. So they ask you to use the Excel z-test to sample for mean. Okay, so this one. All right. And then two sample tests for means unknown, assume unequal. So Excel t-test, two sample assuming unequal variance. Two sample assuming unequal variance here. Okay. Two sample tests for means unknown, assume equal. Then you use Excel t-test, two sample assuming equal variance. And the list goes on. Now you just follow which one to use. Okay. And then this is how you form the hypothesis test. Okay, just same like the one-tail test also. So you want to compare the supplier performance. All right. So we have a purchase order database. Purchase order database, and then determine if the mean lead time for aluminum sheeting is greater than the mean lead time of durable products. Aluminum sheeting durable products. Average lead time. Okay, remember the pivot table. They're using the pivot table to actually construct this. So meaning is that it is the average of these two. This aluminum sheeting and durable products. So how do they get this? They use the pivot table. But this one, they immediately give you this thing. But anyway, if you do the average, right? Let to get the same average equal average of this one, alum sheeting. Okay, close. Okay, you get 7, right? 7. And then over here, okay, 4.92. So for durable products. So durable products, average for this one, all the durable products. Close bracket is 4.9. So you have these two. Okay. And then what else? So determine if the mean lead time for alum sheeting is greater than the mean lead time of durable products. Yep, it is. It is more. When we do the mean, we found out that it is more. Okay. So selecting the proper Excel procedure, when we want to look at if we want to use Z-test, the population variance are known. Okay, to sample for mean. Population variance are unknown and assume unequal. Then you should use the t-test. Okay. To sample assuming unequal variances. And then population variances are unknown but assume equal. Then we use the two sample assuming equal variances. So these two calculate the test statistic, the p-value for both of one-tail or two-tail test, and the critical value of one-tail test or two-tail test. So if the test statistic is negative, the one-tail p-value is the correct p-value for a lower-tail test. However, for an upper-tail test, you must subtract this number from 1 to get the correct p-value. So if the test statistic is non-negative, positive or 0, then the p-value in the output is correct. And the p-value for an upper tail test, but for a lower tail test, you must subtract the number for 1 to get the correct p-value. So for a lower tail test, you must change the sign of the one tail critical value. Okay, so we can follow this example here. Two sample assuming unequal variances. Okay, so alum sheeting data and durable products data. So we can try. Okay, we try following this thing. Okay, what you can do is, you can go to data, data. Okay, data analysis. Okay, data analysis. I think you need to highlight first. Two sample assuming unequal variances. Okay. So variable range 1. So you can highlight this one. Okay. Right. And then the next one is this one. All the durable products data. Okay. Right. So hypothesize mean different. What you can put is unequal variance. Okay, put 0. Okay, cannot. What happened? What happened? Oh. Is it the same or not? Okay, now we have exactly the same thing. Okay, so the variance is not equal, unequal. Okay, observation, we have 13 data, and for this one was the, what you call this, alum sheeting, and then this one is the durable products. So we are more interested in looking at the p-value and also the the test, t-test. Okay. So when we look at this, take a look at this. The second rule is if the test statistic is non-negative, positive or zero, then the p-value in the output is the correct p-value for an upper tail test. So the p-value is 0.00166, which is less than 0.05. Okay. So when you do the critical value, right? Critical value is 1.81. And then you find out that the t statistic is 3.83. So it's within the rejection region. So you reject the null hypothesis. Okay. So in many situations, data from two samples are naturally paired or matched. When paired samples are used, a paired t-test is more accurate than assuming that the data come from independent population. So hypothesis is the mean difference between the paired samples. So this one is regarding the pile foundation. Okay. So we can go here. We try this one again. Look at the pile foundation. Okay, so this one, they already provided you the answer. Pile foundation. Okay, let's look at this one, this example. Test for a difference in means of the estimated and actual pile length, the two-tailed test. So two-tailed test already, when you try to do the hypothesis, it should be equal or not equal to. Okay, so this will give you a two-tailed test. So one is upper critical value, another one is lower critical value. So when you draft a mean, okay, when you do a table, pile number, okay, so these are the pile length estimated. Okay, so when you get the mean, one is this side is 28 and the actual is 34. Okay, you can do the variance and the observation, both the same. We have the Pearson correlation, the hypothesis mean difference, there is 0. Okay, try demo. So the critical value approach decision, we reject the null hypothesis. There is sufficient evidence to conclude that H1 is true. So we reject the null hypothesis because we look at the t statistic it is negative 10.91. Okay, so it's around the rejection region. So that if we use the two-tail, so it's 1.96. So 1.96, so it's very much outside of the, within, okay, outside of this tail. This not within this region here, this 0.95. Okay, look at this one. So the t statistic is negative 10.91. Okay, t is smaller than the lower critical value. Okay, the lower critical value, and then p value is 0. Okay, the hypothesis mean different is 0. So we reject the null hypothesis. Okay, we either use these three level of confidence: 99%, 95%, or 90%. So when we use 95%, okay, you can see that it is less than 0.05. Okay, so that's the rule. Because when we found out that the p-value is around 0, 0.000. Okay. Right. Test for variance. These are the F distribution. Okay, so we rest here first. Okay, then we start with ANOVA in 10 minutes. Okay, we start in 10 minutes for ANOVA. So far, any question?
Not yet, Doctor. Tapi mungkin masa buat ada.
All right, okay. So if you have any question later on, you can always ask later.
Okay, sir.
We will continue with ANOVA in 10 minutes after this, at 9:15.
Okay, sir.
Okay, so we try to finish up with chapter 5. And the last part that I want to share with you today for this session is regarding ANOVA. Okay, ANOVA is a type of estimation, or we could say calculation, for you to estimate the variance. Okay, so let me share with you the screen. First, this one can close. Screen, share screen, share entire screen. All right, so hopefully my voice is loud and clear, and also there is a slide that is also sharing to you right now on your screen, so hopefully you can see. So right now I'm going to enlarge the slide. Okay, so now we're going into the analysis of variance, or we could say as ANOVA, analysis of variance. Okay, so what is a variance? Okay, variance is a spread of results. So what does a spread of results mean? So when you're trying to measure a variation between groups, so let's say when you want to uh, calculate for variance, you have a data. So for example, there is three datas. 100, first data is 100 ringgit. The second data shows you 100 ringgit. The third data also shows you 100 ringgit. So when you do the find the mean, and then the average is around 100, right? Because all of the data shows, all of these three data showing you the same amount, which is 100 ringgit. So when you average it out, average means that you take the purata, whereby 100 plus 100 plus 100, 300 divided by 3 is equals to the average of 100 ringgit. So the average is 100 ringgit. So once you do the analysis, you calculate. So that means that there is no differences, okay, at all between this average. So the variance is 0. Okay. So after that, what if you have another set of data whereby there is 150 ringgit, and then the second one is 100 ringgit, and then another one is 180 ringgit, for instance, for example. So when you do the calculation, the average is around maybe 100. So there is quite a distance of in between those data sets. So when you plot a graph, okay, when you want to know the distribution in the graph, so there is, when it is, if it's 100, right? So all of the data will focus on one side of the graph or in the middle, because everyone is scoring the same thing. So the variance is 0, or if it's only a slight difference, for example, 98 and then 99 and 100, so it's quite in the middle lah, or 110, 90, 100, 110, compared to 150, 100, and let's say 50. Okay, so the gap is quite large. So when the gap is quite large from each other, so you can see the variation or the disbursement in the graph is quite large here and there. Okay, so that is what we want to find out. Okay, if at least one mean is different from the others. Okay, so let's go for the second slide. When we look at the difference in insurance survey data, so determine whether any significant difference exists in satisfaction among individuals with different levels of education. So we can see here, okay, the variable of interest is called a factor. So in this example, the factor is the educational level. And we have three categorical levels of this factor: college graduate, graduate degree, and some college. So the factor is the profitability, level of debt, level of equity, and the size of the company. Okay. So we can use ANOVA. Okay, ANOVA. Where can we find the ANOVA? We go to the analysis tool, the data analysis tool. Okay, so we go to the insurance survey data. Okay, this one. Okay, these are all provided in the WhatsApp group. Okay, so we have this data. Okay, we go straight to demo lah. Okay, this was shown in the slide, right? So you have to calculate the mean first. Okay, college graduate. Okay, it is extracted from here lah. They use the pivot table to get this thing. Okay, so now you can divide it, and then you find the numbers and the average. So after that, you can do this one, the variance. Okay. So the one that I want to show you is how they get this ANOVA. Is you go to the data analysis. Where is the data analysis? Okay, go to data and data analysis. Okay, you find ANOVA. It's either ANOVA single factor, ANOVA two factor with replication, or ANOVA two factor without replication. So you use the ANOVA single factor. Okay, so you can click ANOVA single factor, click OK. So the input range. So which range you want to use? So the range. This one. Okay, so now it appear here. Okay, so they count for you already. They get the sum, and then this is the average, and then this is the variance. Okay, so the variance is provided already. So the distribution of what we call it, the distribution within this data set, we can see that for college graduate is around 1 difference, and graduate degree is around 0.5, and some college is the difference, average of difference between the data between between the datas, this one is around 1.4. 1.4, 0.5, and 1.0. Okay, this one. So when we look at the slide, okay, so the the factor, okay, is about 3.92, and then what we are interested is the p-value. Because the p-value, we use the 95% confidence level, so it's 0.05. So when we found out that p-value is 0.03, then you reject the null hypothesis, because you reject the null hypothesis because your alternative hypothesis suggests that there is a significant difference that exists in satisfaction among individuals with different levels of education. Okay, so that's how you do the discussion. And then we have also the chi-square test for independence, which is the test for independence of two categorical variables. Category, remember, we want to categorize from maybe from largest to smallest, or from the worst to the best. So that is category. Oh, that's ordinal, sorry. Category is gender. Okay, so we look at this example. we have a gender, which is male and female, okay, which and we want to find out what brand preference. So we have a data called energy drink survey data. So a key marketing question is whether the proportion of males who prefer a particular brand is no different from the proportion of females. So if gender and brand preference are indeed independent, okay, independent meaning that they don't have a relationship with each other, we would expect that about the same proportion of the sample of female students would also prefer brand one. Okay, meaning that the same amount of number between male and female also prefer the first brand. So if they are not independent, okay, then advertising should be targeted differently. Okay, if they're not independent, then advertising should be targeted differently. That means when you want to do advertising, you should specifically do a separate type of advertisement for males and another separate advertisement for female. Not actually doing the same advertisement and try to use the same advertisement for the two genders. Okay, so this one why we do the test. So if they are not independent, then advertising should be targeted differently to the two genders. Whereas if they are independent, then it doesn't matter. Okay, it doesn't matter if you have one different advertisement. So the first step is using a cross tabulation of data. So we compute the expected frequency if the two variables are independent. Okay. So this is how you can actually calculate, and we can use the chi-square statistic. So the chi-square statistic also it will be included in the data analysis. So you go to data analysis, you can also find the chi-square here. All right, where is the chi-square? It's not here. Where to find it? Chi-square. Let's go to the energy drink survey data. Okay, don't save. Energy stream. Right. So firstly, you can use the pivot table first. Okay. Right. So use the pivot table to find the male and the female. Okay. So we find the male and the female using the pivot table. So we remember we go to insert pivot table. This one. Okay. Selecting. Okay. So now what we can do is gender, column, brand preference, value. Okay. So what do we want to find is brand 1, brand 2, brand 3. Oh, this is What do they use? Count. Okay. So we go here and then count. This one is sum. Count. Okay. Now we have the same pivot table like the one that is done in the demo. So we want to observe the frequency. Okay. So step one is expected frequency. Expected frequency is the grand total row multiplied by the grand total column divided by the number of observation. So, like that. So this one multiplied by this one divided by 100. Okay. Of course, you need to multiply these two first, then only you can multiply by 100. So, okay, next is this one. So grand total multiplied by the grand total for male multiplied by the divided by the grand total. So once you finish with step one, you move to step two, which is to find the chi-square statistic, which is this one. So firstly, you need to find the brand one. So you need to do this. Okay, just follow the instruction here, and then in order for you to find the total of the chi-square statistic. So once you have this, you just follow this formula, right? And then after that, the step three, in order for us to know whether we want to reject or accept the null hypothesis. Okay, so all of this is being showed here for you to follow. You can just follow the example here in order for you to find the result for the hypothesis. Okay, so that's regarding the example for energy drink survey data. Okay, so that's regarding chi-square test, right? So most of you have already submitted your, what do you call this, your individual assignment, which is good. Okay, so the next one is I will give you your